Let's try our 5 steps again. Step 1, bring everything to one side and get it to be a single fraction. So I have plus 4/5 is greater than or equal to 0. I need to times by my x squared minus 9 to get my common denominator so I can get a single fraction. And I also need to multiply by my 5. So then I can double check that these denominators are common. They are the same. So let's distribute this 5 and I get 5x plus 10. Distribute the positive 4 to get 4x squared minus 36. All over our common denominator. So if I sort all this out, I get that. And ta-da, step 1 is finished. Brought everything to one side and got it to be a single fraction. Step 2, highlight what I'm solving for. I want to be greater than or equal to 0 this time, so I am looking for my positive sections of my sine array. Step 3 is to factor. This is my hard factoring on top. So 4 times negative 26 is negative 104. Do some fiddling with numbers and we find out that 13 and negative 8 will multiply to negative 4, and those also add to my 5. So I'm going to cut up the 5x as a 13x and a negative 8x. That's still 5x, so I didn't change anything. I just exchanged the 5x out. And x squared minus 9, that's difference of squares, so I can factor that. Now I see, what do the first 2 things have in common? They have an x in common. What do the second 2 things have in common? They have a negative 2 in common. And now I can factor this as x minus 2, 4x plus 13, and 5, and x minus 3, and x plus 3. And that is step 3, factoring. Check. Step 4, I need to find my x-intercepts and my vertical asymptotes. X-intercepts are the numerator equal to 0, which is going to give me 2 and negative 13/4. Vertical asymptotes are where the denominator equals 0. 5 equals 0 doesn't really make sense, so I can get rid of that. So I have x equals 3 and x equals negative 3. So now that I have my x-intercepts and my vertical asymptotes, I can move on to step 5, which is my sine array. So I'm going to make my sine array. I'm going to put these 4 things on it in numerical order. Negative 13/4 is the least. Then I have negative 3, then 2, then 3. Wow, this is going to be a big sine array. Now I go over to the side. Negative 13/4 was an x-intercept, so I'm going to write that as a point. Negative 3 was a vertical asymptote, so it gets x equals. 2 was an x-intercept, so it gets a point. And positive 3 was a vertical asymptote, so it gets an equals. Now I do my number lines. This one has a 0 above negative 13/4. Left is negative, right is positive. This one has a 0 above negative 3. Left is negative, right is positive. This one has a 0 above 2. Left is negative, right is positive. And this one has a 0 above 3. Left is negative, right is positive. Don't forget our 2 check steps. So I come over here. Do I have any negative leading coefficients? I look at all the leading coefficients here in these factors. None of those are negative, so I don't need a line of negatives at the top. By the way, if you have more than 1 negative leading coefficient, you do more than 1 line of negatives. Second thing I need to check for is my multiplicity. None of these have multiplicity, so I don't have to duplicate any of these rows. So since I checked for both of those things, now I can just look down my column. 4 negatives make a positive. 3 negatives and a positive makes a negative. 2 negatives and a positive makes a positive. 1 negative and 3 positives is negative. And 4 positives is positive. Phew. Now, I am looking for my positive sections, so I'm going to highlight those. And let's list our intervals. This is greater than or equal to, so because it is equal to, we better do brackets. So this first one's going to be negative infinity to negative 13/4. Oops. Bracket, because of the equal to, union, negative 3 to 2, brackets, because of the equal to, union, 3 to infinity for that last one, bracket, because of the equal to. Now, this answer is actually not quite correct. And here's why. Some of these answers were vertical asymptotes. And we know, we learned earlier in this lesson, we cannot include a vertical asymptote. So we need to see which ones are vertical asymptotes and change those ones to parentheses instead of brackets. And that is why over here, I have you write these like this. If you write it like this, it is very easy to see which ones are your vertical asymptotes, and so those numbers you need to change to parentheses. So negative 3 is a vertical asymptote. It's written as x equals, so I'm going to change the negative 3 to a parentheses. This 3 is written as a vertical asymptote, so I'm going to change the 3 to parentheses. And now that's correct. Another way I've seen students and teachers do this is on their sign array, on the vertical asymptotes, draw your vertical dashed line. And that reminds you that these two are vertical asymptotes, so they have to have parentheses since you can't include them. That should be everything you need to know about rational inequalities now. In the last video, we'll do one last example, and in this one, I'll have you pause the video and try some of it on your own.